special programming language. Shout out to my boy Laurent for the suggestion. The video request. Today we're going to be looking at cow. There we go. And cow is a very interesting language. This is the cow programming language, which you can find on the esolangs wiki, that wiki with all the, here it is on the esolang wiki. So it says, cow is a programming language, blah blah blah. Brainfuck variant, it has 12 instructions, it's Turing complete, we'll get back to that, very interesting proof of that. All the instructions are moos, and it's basically designed for the bovine in mind, for oxen, for bulls, for cows. Because what can cows say? Moo. Dude, moo, come on. And it's pretty interesting. Let's check it out and see if we can write something in it. And who knows, maybe you'll be writing your next big application in cow. Probably not though. So how does cow work? So cow basically has 12 instructions, and they're all variants of the word moo, although some of them are like or oo or so it almost acts as a 3-bit opcode where you're only allowed to use M and O as your 0 and 1, and they don't use all possible combinations. You have an theoretical infinite amount of memory blocks at which you just start at some random location, kind of like a Turing machine. I mean, all these esolangs are always modeled after Turing machines, and that's your, let's say, current block. And you have various commands to do something to your current memory block. Right, capital M, O, capital O. So I like to think of the capital M as the arithmetic. So capital M, and this is like a plus. So when you do this, this will increment whatever block you're looking at here by 1. So now let's say that one goes to 1. Also, the program I'm using to write on my iPad to my computer is the free version, and there is no undo. So every time I write something, I'm going to have to scribble it out and write it again. So sorry about that. Next one is, again, O-M-O-O with a capital O here. So you can think of this as subtraction. So it subtracts whatever the current block is. Next, if you take the lowercase m, O-O, and its other case, these move forwards and backwards like that. So if we put the M-O capital O instructions, or I would say moo, but they're all called moo, so it might get a bit confusing if I say if we use the moo instruction. So I'm just going to say like that. So then this would now be pointing to this block, right? Instead of that other one. And if we did, let's say, this instruction, then this instruction, and we had started pointing at this one, we would go 1 over and increment the memory block to 1, just like that. Next, we have O-O-O, or the OO instruction. This zeros the current memory. So this one will make whatever memory block it's pointing at to 0, and you're pointing at it, and you ran O-O-O, then this would immediately go to 0, alright? So the next command is a pretty useful command. It is M-O-O, capital M-O-O, so capital M with moo, spelled normally. And this character from stdin and prints. Although not at the same time. The way moo works, or capital M-O-O works, is basically if the current memory is 0, so yeah, let's say you're looking at this one and it was 0, then it'll take a character from stdin and put its ASCII code as that character. Let's say if you type the letter G, this would then become 71, right? Because that's the ASCII code to G, and then you call moo and the current memory block has a number that's not 0, then it'll just print whatever ASCII character that is. So this one's actually changes behavior depending on which memory location, what is stored in the memory location that you're currently at. All caps, This just prints the memory block as an int, so this would have just printed 71, not G. And finally, this time all lowercase, reads an int and puts it into memory. So these all have user interaction. So these are the easy parts of cow. These are all lowercase moo command and the all uppercase moo command, and these basically work like a loop. So the way the all lowercase moo command works is it goes backwards in all the commands and looks for a matching all uppercase. So I should have probably written these in the other direction. So moo. Alright, so this one will go backwards, skipping all moo commands until, again, let's just say there was moo here, one like this, a 0 in the register. I don't know if this does anything. So skip all of these and then look for this command. Basically, once you hit the all lowercase moo, you go all the way back up to the all uppercase moo and check if your current memory block is 0 or not. If it is 0, you again skip all the way and then past that original moo and continue execution to your other moos. If it's not, then you just keep going like this and you'll eventually hit this moo again and go all the way back. So, alright, and here's the final command in the cow programming language before we can start coding for bovines, and that's the MMM command. And this basically accesses the register. So cow has a single general purpose register that lives outside the memory blocks or the tape, which you can access with the MMM command. And here you are at number 7. Then you execute the MMM command, and basically this is going to put whatever the current value is, so the 7, into the register. But if, let's say, this was assuming the register was 0 before, and now we're pointing at that 4, let's say, and then we execute the MMM command again, seeing as how the register has something in it, this time instead of copying 4 to the register, it pastes the register, so this will become 7. That'll become 7, and then it's going to reset the register to 0. M, capital O, capital O. And this takes whatever value is in the block, let's say 2, and executes that as a command. So, all the moos that I've been listing so far actually have a proper ordering corresponding to the code and executes that command. So that's how moo with 2 O's operates. And if it's an invalid code, the program halts. And if the code is 3, then it's an infinite loop. So now let's bust out the compiler and start writing some cow. Let's start mooing, man. I haven't mooed in a minute, bro. I haven't mooed in a minute, in a fat minute. Alright, so if you go onto the cow programming language website, which I can link in the description, but it's bigzafod.github.io/cow, I guess. This is what it is. He's got some nice examples, this cool little ASCII art of a cow, and he links the GitHub to where you can get a cow compiler. Zafod wrote a cow compiler for us, and actually what I'm going to do, I've already started, what I'm going to do is just clone this whole repo. Alright, so here we are in Emacs. I'm just going to open a shell here, and the theme for the emojis doesn't work so well in Emacs. I haven't figured that out yet, so we're just going to use Ignoster. we're just going to use agnostic, and I'm going to just bring this up for you so it's a bit easier to see. So let's go to YouTube and make a new, I already was playing around with this earlier. Let's go, we'll call it moo. Let's call it moo. So we're going to get clone, we're going to get clone that repo. So here it is, here's cow. Boom, here we go. Here we go, cow at master, moo at master. And he's got the source over here. So these are C++ programs. I guess one of them is a K program. These are C++ programs that will take cow source and output a binary, a cow binary. So we can, alright, so here's the cow compiler that was written. Let me just, perfect. Okay, so basically it looks like instead of compiling it to assembly, which is such a laborious task, they're just transpiling it, I guess you could say, or compiling it to C++, and you can tell that from these kind of wacky strings that they're putting here. So this is going to be printed into a file, and they transpile it into C++, then they run G++. That's what these compiler flags and stuff are here. With a capital M, we'll take in an input, and moo with a capital M, we'll output it. And so here we're going to be on some memory block, which is defaulted to 0. Then here it'll take in, and then here we're going to have some ASCII code here, and we're going to output it. And you might be wondering if I can just do this in cow just randomly, and that is yes. Any character that's not in the actual table of characters just gets completely ignored. So these will just act as comments. But if you want, I can do this for you. There, look at that, look at that. And we'll do this. Do that. Look at that. Now it looks like real comments, or at least, you know, whatever language you want. These could also be slashes or whatever. Alright, here we go. Echo car.cow. Let's go into the compiler. Cowcc, actually /cowcc, because I'm not putting that in my path. Echo car.cow. Here we go. And away we go. Boom. Looks like we have a .cow.out, or we have a cow.out. Let's do it. Let's go cow.out. Alright, so it looks like it's waiting for the input, A and A. Our first cow program. Our first cow program. Beautiful. Beautiful. Let's do something nice. Let's do hello world in cow. Let's do hello world in cow. So to print a constant string, right, you actually have to run the cow command, or sorry, not the cow command, the moo command, a set number of times to get that register up to a certain number, and then you just run the moo command. And then you move one over, increment it all those plenty times, then you run the moo command. It's very simple and it's super tedious, but let's do it anyway. Let's do it anyway. So there's this nice table in the man page that lets you easily show what the ASCII value for everything is in, if you say man ASCII. So capital H is 72, as you can see. 7 up there, 2 over there. So we're on the first block. We want to take ASCII, so that's 72. So we're going to increment that block 72 times. So let's replace that. So increment is what? Increment is what? Increment is capital M O capital O. Right? That's the increment. And now let's just do Well, we already did it once, so we'll do 71 dot, and here we go. That should be 71 dots. Not a big deal. Here we go. Boom. H. We did it. We did it. So to print hello world, we just repeat that over and over. Alright, and a real quick thing to remember is every time you gotta move the memory block over. You gotta move the memory block over. So we can write M-O-O. So now we're pointing. Actually, another way you could do this is just in a Python REPL write ord of the character you want. So that's actually a lot easier. 108. So it's 108. Yeah, I have to move 5 or any more, but let's just stick with 5. Hello world. Guys, we just wrote hello world in cow, dude. We wrote hello world in cow. We wrote hello world in cow. Amazing, amazing. And of course, I'm still in the source directory for cow program, so that's super silly, but there we go, dude. We did it. We wrote hello world in cow. We wrote hello world in cow. Alright, so that's super useful, but let's say you're at a coding interview, you know, you're at Facebook, Google, Microsoft, whatever, and they're just trying to get a feel for you to see if you're like going to be a good candidate or whatever, and they ask you a simple question just to make sure you're not lying before they hit you with the hard leak codes. They say, oh, okay, could you make, I don't know, like a Fibonacci program? And obviously on all these interviews they say you can use whatever language you want, so clearly you're going to reach for cow. So you're going to reach for cow. So how would you write Fibonacci and cow? It's a little bit of a more complicated program. Let's go to that. Let's try to write Fibonacci and cow so you can really impress those guys.
So first we'll just add, move over one, so now we have 2 ones, and now let's move one back, and we'll begin the loop. So first we want to take a copy of the first one and move it 2 over as a temporary one, okay, because we don't have a temp one here. So how do you do that?
That's fine, it's not a very cool program anyways. But let's just compile it and see how it does. And so that should be Cowsay, and what we call it, fibcow. Let's just see how it does. Nice, nice, looks pretty good. Super duper slow, pretty much the slowest Fibonacci program I've ever seen. Buffer overflows or integer overflows right away, so none of the answers past this point are any good. But you know what? It's a program, it's written in cow. Well, what more could you ask for? What more could you ask for? So there we go. And here we are. That was Fibonacci, so you bust that out, your Google interview should be good to go, I imagine. Alright, so as a final thing, here's something super tragic, at least that I find super tragic, with these esolangs. Sure, they're Turing complete in that they could do any computation, but they can't actually do anything that another language could. Namely, they have no system calls, and they actually can't interface that well at all, and it's really up to the implementation. So the really only the way that it could be so complete is if you implemented the entire operating system in it. It can't really interact. I wish there was a term for some computer language that is not only Turing complete, and first of all, they're not even, right? Like an infinite memory and all that, but like Turing complete, but also like Linux system call complete, so that I can at least do something interesting. And the reason I bring this frustration up with you, dear viewer, is because there's this very famous program called Cowsay, right? And you just write Cowsay and a thing, and a little cow comes and he says the thing. Okay, it's beautiful. It's kind of a funny program. It's written in Perl originally, but I'm sure it's been rewritten 1,000 times. And I thought it would be so great if only I could write Cowsay in cow. Write Cowsay in cow. Then it's Cowsay cow. Would be so awesome, except here's a problem. You can't access command line arguments in cow. You can't do it. It's just not built into the language. It doesn't have that functionality. So I was thinking, how could I possibly make Cowsay in cow? How's it possible? So naturally, I gotta fork the compiler to give it this functionality. Alright, so basically my idea to change the compiler to accept command line arguments is to more or less have the tape, what it's gonna do when it gets compiled is check command line arguments and start putting them in the tape, and then start you off here at a 0. So that'll always be the case. There'll be a 0 at the beginning, whatever it was in the command line arguments, then a 0, and so on and so forth. And the good thing about this is actually it's backwards compatible with already pre-written cow programs, because if this didn't exist, then it would just be zeros and you'd be left with the regular cow program. But if it does exist, then it just copies it to the left. So if you look at the compiler source, again, it's more of a transpiler to C++, which it just compiles again to the cow output file. You can see that it uses this, let's go down to somewhere you can see it. It uses this vector that it calls m. Right here, it uses this vector that it calls m to store all the information. And so basically what we're going to do is at the beginning of every main file check if there's a command line argument, and if there is, we'll push all of those arguments onto the vector at the end of the vector. Plus cowcomp. Alright, beautiful. Now we have cowcc2. Let's do echo moo. Looks like it failed. Right, so sorry about that. I just reset this as the screen because I really couldn't see what was going on. Okay, so we have to write /cowcc. Again, I totally forgot about that, so we can just do that. And alright, so let's write a echo program with the new version of cow that the fork compiler provides. So first, we know that it nests it in between two zeros, right? Blah, 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 right? So these are like numbers, for instance. And we start here. So we got to move back 2 times to get to the first number. So we go MOO, MOO. Then we can start looping to get to the first 0. The first 0. This is just the specifics of my implementation. So it nests it does a 0, all the ASCII, then another 0, then it's where you start. Moo in all caps. Then we want to move back, right? We want to move back and end the moo loop. So this will just carry us all the way till we get here. And I'll just carry us till we get there. Next we want to move 1 over and begin a new loop. In this loop we just print, then move 1 over, and that's the end of the loop. And that should be the whole thing. So these two move us back to where the letters start, where the arguments start. This will float us all the way to the first 0. This will move us 1 forward. Then this will start printing forwards from the first 0 to the 0 that we reach at the beginning. So with any luck, this should, I put in the examples, and we just do ./cow.out, hello world. Ta-da! So we've written an echo program in cow. This is great stuff. And here it is in case you wanted it a bit bigger. So now how do we implement Cowsay? Well, let's see. Cowsay, I don't know. Something like that. So there seems to be a cutoff for Cowsay at a certain amount of characters, right? You can't just have it overflow the full screen. But I'm once again going to totally ignore this just for the sake of this program. So because it's already pretty much getting late and there's a lot of work to do, I'm going to cheat and call that echo program the talking, and then we're just going to print the cow and call it a day. But just so we don't have to print this cow, which is all these characters, with the regular moo version, there is actually an interesting implementation of a prologue program that somebody made online where it uses some interesting arithmetic to get the ASCII code in less time than it would take just to print a lot of moos. It still prints a lot of moos, but it's a lot less. So if I can get the Cowsay, I'm not using a Mac, by the way, that's just a script I wrote called pbcopy, and we want to eliminate this stuff and go like that, generate. So here's the beautiful, look at this, look at this, look at this and marvel. Okay, enough looking, let's get to work. We'll copy that and come back here to Emacs and go here and shift insert. So it's super strange noise coming from outside. And yeah, it looks beautiful, looks beautiful. And the good thing about a cow program is you don't have to work that hard to obfuscate it. No C code obfuscation, you know, those JavaScript obfuscator. If you want your stuff to remain closed source, just write in cow. Just write in cow. Everything's a blob by default. Okay, yeah, so that looks good. Let's do that. Let's come here. Cow compile it. And I can't even see what's going on because my size is totally ruining my screen. Okay, so now we're going to do cow.out hello cow. It looks bad. It looks very... Why is that? Why does it look bad? Guys, can you answer me that? Because we need a new line after hello. So what are we going to do? We're just going to do this. We're just going to do this. Going to go all the way up here. We're going to go MOO. We're going to print a new line, which is 10. Oh, that's interesting. I don't know it was 10. And whoops, I'm missing every key here. Yeah, that should be it. And MOO and move one over. That should be good. That should be good. Let me get that out of the way, and we're going to exit here, and we're going to... I love that the compiling takes so long. And... Guys, it's Cowsay in cow. It's Cowsay in cow. What do you want from me? What more do you want from me? We had to fork a compiler just to make it work, but you know what? That's just the way she goes, baby. That's just the way she goes. And you know what? You know what? I actually think that we should put a new line at the end. We'll put a new line at the end. Man, I should really have the makefile for this. What do you want? We did it. I don't know what to say. I don't know what to say. I mean, I will take the Turing Award, but I will be humble about it. That's all I'm saying. That is all I'm saying. This is cow, say, and cow, guys. It's cow, say, and cow. It's cow, say, and cow. Amazing. Amazing. Finally, I'd like to leave you with Cowsay saying its own source code as a cow in cow. Beautiful. So this is a cow saying the Cowsay source in cow. So it just looks like he's mooing, but he's in fact saying his own source. Beautiful. Moo.